Hi everybody, welcome back and a new session in States of Matter. We are going to talk about mixture and substance, mixture of substance and diffusion. A mixture is more than one compound mixed together. More than one different compounds are mixed together, like water and salt. Water is a compound and salt is another compound. When they mix together, they give us a mixture of the salty water. If we take pizza, for example, pizza is a mixture of different components, of different compounds. Okay, so mixture can be homogeneous or heterogeneous. Homo means similar. Homo means similar. Hetero means different. So homogeneous mixture is a mixture where you couldn't differentiate by your eye the layers of the compounds that are mixed together. For example, when you mix water and salt together, they are completely dissolved. And at the end, you have a clear solution. You couldn't differentiate the particles of salt anymore. So this is the homogeneous mixture. Okay? The opposite is heterogeneous. Heterogeneous is mixture where you can differentiate its components, like oil and water. When you mix oil and water, you still have separate layers of oil and water, and you can't see where is the oil and where is the water. Okay? So again, mixture can be homogeneous or heterogeneous. Homogeneous where you couldn't differentiate its components, and usually it is solutions. Okay? For example, salt solution, which is salt and water, sugar solution, which is sugar dissolved in water, and cobalt 2 solution. Heterogeneous can be colloids or suspension. Both of them, the components can be differentiated, but in colloids, you can only differentiate them under microscope. You couldn't differentiate the component with naked eye, like the milk, for example. Milk is colloid, but you couldn't differentiate by your eye where are the proteins, the fats. Okay, but under microscope, you can see the components. The blood has red blood cells, white blood cells, and serum. And by naked eye, we couldn't differentiate them, but under microscope, we can see different components. Okay? So that in that case, the case of colloids, the mixture has the properties of both solution and suspension. There is solution and there is suspended particles inside it. So both properties will go to the mixture. So example, as I mentioned, milk, blood, hair gel, mayonnaise. While suspension, you can clearly differentiate its component by naked eyes, like oil in water, sand in water, dust in water. All of these can be differentiated by naked eye. In general, solutions have two components, one major and one minor. So it consists of solvent, and the solvent usually will be in high ratio, okay, and solute. A solute will be in the lower ratio, or it is a minor. Homogeneous mixture of two substances or more. This is the solution, the definition of solution. As we mentioned before, it's homogeneous. So, and why it is homogeneous? Because the solute is equally distributed in the solvent. And that's why we couldn't differentiate the particles of the solute. Solutions are very important for biological processes and for chemical reactions. Like, for example, the blood. The blood is very, very essential biofluid for biological processes, for vital processes in our body. Okay. And also, the solutions have different states, have different physical states. Solutions can be gas solutions, liquid solutions, and solid solutions. Suspension is a heterogeneous mixture which contains small particles of insoluble solids. So these particles are insoluble, so we can see them, we can differentiate them, or droplets like the oil in water. And the liquid is insoluble and cannot spread, suspended throughout the liquid. Also, we have a different term, which is precipitation reaction. A precipitation reaction is a chemical reaction in which an insoluble salt is prepared. So this reaction will give an insoluble salt, an insoluble compound, which will precipitate at the bottom of the tube. So solutions, again, solutions are homogeneous mixtures, and they can be classified according to their physical state into gas, liquid, alloy. So there is gas solutions like the air around us, okay, liquid or alloy. So gas solutions, the solvent is gas and the solute is gas, and the solvent usually has the higher ratio. Liquid solution, the solvent is liquid and the solute is liquid, or the solvent is liquid and the solute is gas, or the solvent is liquid too, but the solute is solid. Like what? Like, for example, solvent, liquid in liquid. Solvent is liquid and solute is liquid. Like alcohol in water. Okay? While liquid, gas in liquid, the solute is gas and the solvent is liquid. Like fizzy drinks or sparkling water. This is carbon dioxide dissolved into water. So the solvent is liquid, the water, and the solute is gas, which is the carbon dioxide, carbonated water. The other type of liquid solutions, solid in liquid, the solute is solid and the solvent is liquid. Like sugar in water, sugar is solid, and salt in water, salt in solid, and water is liquid. Alloy are a mixture of liquefied metals together, okay? And after they liquefy and mix it, they solidify again. We will talk a bit more about that later. So we come to the term of solubility. Solubility is the ability of solute to dissolve in a solvent. How much the solute is dissolved in that solvent. Or we can define it in another way, which is the ability of a solvent to dissolve a solute. Both are the same, both definitions are the same. For example, sugar is able to dissolve in water, and in that case, sugar is soluble in water. But oil is unable to dissolve in water, and in that case, oil is insoluble in water. Solubility of solid in liquid has 3 degrees of solubility. Unsaturated solutions, or saturated or supersaturated. For unsaturated solution, the solvent can accept more solute. For saturated solution, the solvent has a maximum amount of solute and unable to accept more. The saturated, the solvent can accept more solute after saturation by heating. Again, if we take sugar and water example, okay, so If you have a cup of water and you put sugar, when the sugar is totally dissolved and no extra sugar exists in the cup, so this solution is unsaturated. Why it is unsaturated? So because the solvent, the water, can accept more sugar. You still can add more sugars. Some of the water molecules are not bound to sugar, so it can accept more sugar. But when you keep adding sugar to that water, and at the end there are a small amount of sugar remain at the bottom of the cup and cannot be dissolved, this is unsaturated. It is saturated solution. Why? All the water molecules are saturated with sugar and couldn't accept all. Consider if you're hungry and you eat a lot, you will reach to an extent that you couldn't eat anymore. So you are saturated. You're already saturated. You don't need any more food. Okay, this is the same. When the water couldn't accept more sugar and the sugar remain at the bottom, so that water is saturated with sugar. But if you take that saturated water, which has some sugar at the bottom, and you start to heat it, so the sugar will be dissolved and you can add more and dissolve them and more and dissolve them. This is super saturated. So why it's super saturated? Because the solvent after saturation can accept more and can dissolve more solute. And this happens when you heat the solutions. Like if you prepare the syrup for sweets, okay, you add so much sugar with water and they dissolve. When they heat and when they boil, they dissolve. This is super saturated solution. We come back to some definitions. We already mentioned some of them. So soluble and insoluble, we already mentioned them. Miscible is if two liquids of a completely uniform mixture are added together, they are said to be miscible. Okay, because they are already mixed together. So alloys, as we mentioned, mixture of elements, which is usually metals, and when they are added together, they gain more properties which are useful for particle purpose or for manufacture, for example, like the tin alloy of tin and lead, which has a low melting point. Another alloy is gold and copper. Sometimes people, specialists, mix gold and copper to give gold more flexibility and more strength when they are formulating the gold. So we mentioned the saturated solution. The concentration is a measure of how much solute is dissolved. Like, for example, if you dissolve a large amount of sugar in water, there is concentrated solution because there is a high amount of the solute dissolved in the solvent. But if you add a small amount of sugar in water, this will be diluted solution. The concentration is high. Okay, so when the solvent has high proportion, the concentration is low, so the solution is diluted. But if you add high proportion of solute, the concentration is high, and this is a concentrated solution. So solubility is a measure of how much of solute dissolves in solvent under particular temperature. What about the solubility of a gas in a liquid? For example, the carbonated water, the fizzy water, or the sparkling drink, the sparkling water, and the soft drink. When we increase the temperature, the gas will be less soluble in water. So the solubility of gas is less when the temperature is high. So they are diversely proportional. But if the pressure is increased, the gas will be more soluble in water. Again, temperature is high, solubility of gas is low in water. Pressure is high, solubility of gas is high too in water. For example, the sparkling drink or the sparkling water, this is water with carbon dioxide dissolved in it. To dissolve the carbon dioxide in this water, that process happens under pressure. And if you notice when you open the bottle of a sparkling drink, it will psh. This is the release of the stored pressure because they are dissolved together under pressure. And when you open it and this happen, you will find that with time, the gas inside the drink will be less because the gas will escape from the drink because when the pressure is low, the solubility will be low too. That's all for today. Thank you guys.